Now we're going to get into fingerprinting the web application framework and the web application itself. OWASP in the guide here, as you can see, 4.1.8 and 4.1.9 have been combined into one section of testing. This technique is essential in understanding the components of the web application we're testing. It can also reduce our efforts by using known vulnerabilities of the identified components. Right now we'll look at several methods to identify these components, from inspecting HTTP headers all the way down to error messages. Let's go ahead and get started. Scroll down to HTTP headers. Okay, so the simplest way to identify a web framework is to inspect the X powered by field in the response header. If it's not disabled or obfuscated, it should reveal the framework being used. In their example here, they have the Mono framework in the X powered by header. We can usually test for this by using netcat or using the curl-I and pointing it to that top level domain in order to analyze the X powered by field in the response. The next up we have cookies. Some web frameworks set specific cookies which can help us identify the framework in use. For this example, a cookie named CakePHP indicates the use of the CakePHP framework. Just be aware that cookie names can be changed in the configuration, but it's less common than HTTP header manipulation. In order to review the cookies, we could open the browser's developer tools, or we can also see the cookie set parameter on the server response once logging in. Now when it comes to HTML source code often contains markers which can identify a framework. You can look for HTML comments, paths to framework specific resources, and specific script variables. You can often find information in the head section of the HTTP response, in meta tags, or at the end of the page itself. In order to take a look at HTML source code, will look very similar to the picture here, but you can just right click your web page and click View Page Source to analyze those fields. Very straightforward process. Let's head back to Okay, so in the case of specific files and folders, every web component has its specific file and folder structure on the server. A technique known as forced browsing or dir busting can help us uncover these and identify the web application itself. We can brute force known folders and file names and monitor the HTTP responses to enumerate the server content this way. You can use a tool like dirbuster, burp suite, or even zap to perform a dir busting attack on the target website. This will usually involve trying out a large list of directory and file names and seeing how the application responds. Certain responses could indicate the direct use of a particular web application framework. After taking a look at specific files and folders, we'll want to take a look at file extensions in the URLs or the hyperlink of the website, which can provide clues to the web technology being used. These extensions are associated with server-side technologies, and knowing these can help identify the underlying web application framework. Testing file extensions can be more of a lengthy process, but you want to ensure that you're familiar with various file extensions and their related technologies such as PHP, ASPX, JSP, or even Python, for example. Now usually how this works is you want to manually inspect the website. Just navigate through the website and browse different pages. Pay attention to the URLs and any hyperlinks on the website. Look for file extensions at the end of URLs and or other hyperlinks. You can also use a web scraping tool or a script to automatically fetch the URLs from the website. Also checking for file extensions and using other tools such as Scrapey, Beautiful Soup, and Python just to scrape the web application a bit faster. Lastly, for file extensions, we have the analysis portion. This is where you want to analyze what you found. For example, if you're browsing through a target website and index.php pops up, the PHP extension indicates that the site could be using the PHP framework. From there, you want to look at the resulting error message to see if it reveals any information about the web application framework being used. You can do this with several tools as well, such as WhatWeb, Wapalizer, and WhatRuns. Let's talk about those tools real quick. Okay, so WhatWeb and Wapalizer are both excellent tools for fingerprint web application frameworks. WhatWeb uses a variety of matching techniques to identify frameworks, while Wapalizer works at the browser level, providing quick results about a technology stack. Here in my browser, I have 3 extensions: Wapalizer, BuiltWith, and WhatRuns. Here's the output of WhatRuns. This runs passively as you navigate through the applications. As you can see here, as HSTS is enabled on this site, we have jQuery 3.4.1. This is in general what Wapalizer looks like, and you can export this out to a CSV file. Now let's take a look at the BuiltWith extension, just to see in general what technology is present on the website. Alright, so we have WhatRuns, and as you can see, Google Analytics is consistent across all 3. jQuery the same. This is basically the file. These are basically some tools within the browser you can use to get a solid fingerprint on the web application itself. Manual testing, you can usually get this information from server responses or analyzing the traffic in general during testing. In conclusion, fingerprinting the web application helps us better understand the application, potentially reducing our testing effort and producing more accurate results. Always remember, these techniques might not be 100% accurate, as website owners can obscure and modify these identifiers as they always do in the real world, but they form a valuable part of our testing toolkit.